Okay.
So could you see my screen here?
Yes, yes.
Okay, could you hear me clear?
Yes.
Okay, that's great. Okay. So today I wanted to show you the whole process for task 1. Okay, I will show you this time. I will show you in the notebook, so Jupyter notebook tutorial. Okay, so first, if you want to use the Jupyter notebook, first you need to, okay, so make sure you have activate the proper environment here, and then type this Jupyter notebook, type this command in the command line, and then press enter. You will see here it will open a notebook in your browser. Okay, so let's go to the, so this is for the our class. I just finished this tutorial. I will upload this after this. Okay, so the the tutorial I made is for task 1. Let me zoom in a little bit. Okay. Okay, I cleared all the output. So okay, so first you need to import some necessary packages. Okay, and since as some of you mentioned that, yeah, that's a good point. Because for some attacks, it will take time. So in that case, or in any case, you can generate a subset, a smaller data set for your experiment. So this is optional. I upload this file, subsampling, this API helping you to subsample some the data, the benign sample, as well as the as well as the corresponding labels, and save in the same order. So I provide this to you because I want to sample the data that equally from each class. So I provide this to you. When you are using this one, you need to provide the data. So here, the benign sample and the corresponding labels and the number of classes. In this task, if you are using MNIST, this number of classes always be 10. So this will be 10. If you are using a different data set, that will be a different story. Okay, the ratio here, I set the default ratio as 10%, but you can modify this, and you can provide a file path and the file name, and the sampled files will be saved in this place with the prefix as subsamples, and the file name actually just as part of this name, and the ratio, and I attack the time step here. So the corresponding samples will be named as the, yeah, with the prefix as subsamples. Okay, so this is the new API. You might or might not use it. Okay, so with this one, we have an optional step, so you can prepare a smaller data set for your experiment. So if you want to use this one, you only need to do a subsample once. So, and generate the AEs using the sample you get from this step. Okay. So this is the example for subsampling. For example, currently, I don't have anything here. So I also have a Python example for this case in this file. So this is the main API you need to call to finish this task. Okay, so first we need to load the configuration. So we need to load, basically we need to load the nice sample and the corresponding label, and then just call it like this. So we need to pass the benign sample, pass the corresponding labels, and the number of classes is 10, as we just mentioned, and the output path, I make it results. Okay, so I want this MNIST display in the names. Okay, when you run this, okay, if you can see a number here, that means this slides has been run, has been successfully run. Okay, then you check this results folder. You can see you have subsamples here.
Ying, can I make a comment on the results folder? I just wanted to mention that because Git doesn't let you upload empty folders, you'll have to create the results folder. Like everyone will have to create their own results folder for that to work.
Oh, yes, you're right. Thanks for mentioning that. So if you encounter something, some error, cannot find some file or some path does not exist, you just need to check whether this folder was there. So after you generate if you decided to use use a different sample to generate the AEs, you need to maintain this in the JSON file. So currently we maintain it in this data MNIST JSON in this file. So first you need to copy the generated subsamples to this location. And then you need to replace this subsamples with the name we just get here. Yeah. Put it here.
One comment, yeah. Ying, does it make sense for these, like for example, expecting that a folder exists somewhere, we create a bash script to create all of these folders and subfolders for these? How many of these folders are expected?
I think we, in my cases, I only need results. This is the only folder I need. I mean, you need to create. But if you specify a different folder and I think I can do that. Yes.
I mean, if there are some, so what I meant is if there are some like dependencies in terms of like location of like the result, location of the model, whatever, we could, or one of the students could write a bash script, then like simply one can run it before running the code, if that makes sense. If that's only one folder, that's probably not it. But if there are several of these, maybe we could write a bash script for that.
Yeah, in my tutorial, this is the only folder that's required to create. So, but in your experiments, if you specify a different folder, you need to make sure to create those folders. So, okay, let me show you the JSON file. So if after you generated the subsamples, just replace this file subsamples. First, you need to copy this to the right place. So here, you just replace this one with the one you generated, and replace this label with the sub-labels just generated. Okay. And then now when you get the data, you can we can now generate adversarial examples. So this is the process we generate the example. Okay, the Python example was this file. So mainly we need to call this API to generate the examples, the AEs for you, and you can check in this file for the tunable parameters for each attack method. So it's slow on my computer. Okay. So for example, I guess you guys have been familiar with this FGSM. For example, you are going to generate AEs using CW. You can check this function. Just so all of these guys, so whatever we get from this attack args, they are tunable parameters for this attack. So if you want to generate the AEs using different attack methods, you just check here for the tunable parameters and config in this attack zk mnist JSON file. Yeah, in this JSON file. Okay, so here, this function, we shown an example to generate AEs for you. So we require a model is in an instance of this weak defense, this class. And this model will be the targeted model for the attackers to attack. And this AE, this data are the benign samples we generate the AEs for, and the labels are the corresponding true labels. And these attacks, you just define in that JSON file I just mentioned. So if you wanted to save the generated AEs, you make it true and provide a place to save the example. Okay, so this is, so basically when we get this these configurations, we will generate all the AEs you listed there. So basically we will iterate it. We will read the configurations for attack one by one. So when we get this one, we simply call this function. This is the generate function I mentioned here. It's the API in this attacks.attack in that file. So you need to pass the targeted model here. You need to pass the data loader. So here the data loader consists of the label and the data and the label, and the attack configs. So here we just feed the configurations of the corresponding attack to this method, and then it will return you some generated AEs. And when you get these AEs, we can do some prediction. So here we use the targeted model to predict, to see if the generated AEs can fool this model. Yeah. So, and you can get the error rate here. So here I will show you you can also plot the AEs to see, I mean, for debug or something else. If you don't need it, you can simply comment this part out or just delete it, or make this one 0. Okay. So here we just, so before you generate the AEs, you need to load the experiment configurations. What we need here is the model. We need the data. We need the setting of the attack. So we get all this stuff from the JSON files. So we can load the targeted model, and we can load the files, the data, load the label. So in this case, I will only generate five examples for you. Okay. Yeah, after you get everything done, you can simply call this function and pass the values. Okay. So we can see some processing here. So we first load the targeted model, and then generate AEs using this attack. And the error rate of these two examples are 1. So basically, these two samples can fool the targeted model, as we can see here. So this is the method we generate this image. And previously, the true label for this one is 7. And now the targeted model think this is a 9, and this one as well. So it was 2, but now I think this is 8. Okay. After you generated the AEs and save the AEs, for example, if we save the AEs with this name, and then you need to update this maintain the JSON file. If you don't want to, you can either create a new one similar to this one, and simply put your own AEs in here. I mean, for this one, for this value. Okay, so here, if you don't want to, I mean, you want to use the same structure of this one, you can create your own with a different name. So you can load the configurations from your own JSON file, and then here you just put your AEs here. Then you don't have to update in the code. You don't have to update the path. But if you want to maintain everything in the same JSON file, you can add one more item in this this data analyst JSON file. So, for example, if you can add key, for example, task 1 AEs, and then, okay, let me show you an example here. For example, we just maintain that in the same JSON file. So I add a key here. So you can maintain your AEs like this way. But if you maintain it like this way, whenever you want to load your own AEs, you need to get your AEs like this. So you need to provide the right key here. Okay. So now we get the AEs. The next step, we need to evaluate the AEs. So the Python example is in here, evaluate model. And the API you need is this error rate. Yeah, I would like to thank who I caught my bug. Yeah, previously I counted error rate in a different way, but I changed my mind in the last minute to use a totally different opposite algorithm. So that's, and I forgot to remove that line. So thank you for caught the bug. Okay, I have fixed the bug and uploaded.
Who caught the bug?
I think
it was me.
Yeah, thank you.
Who?
It's awesome.
Me, Andrew Wunderlich. Me.
Andrew. Okay, thanks, Andrew.
Thank you.
Yeah, we love to hear these bugs, right? Find them.
Yeah, yeah. Because I think at last minute, I think this is, I mean, more simple. I mean, easier to understand. So I changed the algorithm at the last minute. Okay.
Yeah.
So yeah,
they have points,
evaluate.
right? We consider it when we give
Yes.
The final scores. Yeah.
Yeah. Yeah. So this method was copied from this Python example. So here we evaluate the AEs using, so here, the undefended model. So here, this undefended model actually is the same model, the same target in this generate AE step. So it's the same here. It's the task. It's the target. Yeah, it's this one. So these two models are the same because I mentioned it in a different context. I just used the corresponding name we referred in that context. So, but I don't want to confuse you guys. So I just mentioned it here. So this target model, when you generate the AEs, is the same model when the same undefended model when I evaluate the AEs. Okay. So in this example, it required the transformation configurations. This one basically it contains the informations of the weak defenses in the ensemble. So it's a dictionary. And this model configurations, it's also a dictionary we loaded from the JSON. It contains some information regarding the models, for example, where the models locate, something like that. And this data configuration, it can be the data-mnist.json, where you maintain the generated AEs. Okay. So here I first load the baseline. So the baseline in this case is actually the PGD adversarial trained model. Yeah. So first I load this baseline model, and I load this undefended model. And then, so we wanted to evaluate with this ensemble. So in order to create this ensemble, you need to load the WDs, the weak defenses. So when you get the weak defenses here, we can create an ensemble in this way. So the classifiers are all the ensembles in this, are all the weak defenses in this ensemble. And strategy you wanted to use for this ensemble. So in this case, I create an averaging probability ensemble. So you can check this. I think it's in the ensemble file. Let me show you here. In the ATHENA. Okay. If you are not sure what kind of ensemble strategy you can use, you can check here. You can check this one. Actually, if you are using if you coding in IDE, when you refer to this object, it will provide you, when you press a dot, it will provide you a list. So in this task, this 3, 4, and 5, there are no difference. We just refer to this. I mean, the algorithms are the same. They just use different level of output to do the to compute the results. So in this case, we only have probabilities. So you need to use this one. Yeah, if you are using the rest, since you are using the output probabilities, you will always get the same result. Use this averaging probability. And if you would like, I will suggest you to also use majority voting as well. Okay, so these two, 1 and 3. Yeah, so you need to provide the weak defenses, and this is a list. Weak defenses. You maintain a list of classifiers, and you pass it to the classifiers, to this parameter, and then you need to find the strategy. Okay. And then next step, we wanted to load the benign samples. Why do I need to do this? Because according to the definition of this successful rate, we need to first exclude the samples that was misclassified, the benign samples that was misclassified by the undefended model. Because if the model cannot, has been fooled by the benign sample already, it's not. So yeah, the AEs might also fool them, but that's not the, I mean, that's not caused by the perturbations, because the undefended model has already make mistake on that sample. So we need to exclude this kind of samples. So that's why we need the benign samples here, and then the true labels here. Yeah, and then we get the corrections. So these corrections are the indices of the samples that are correctly classified by the undefended model. We can see here. But you don't need to know this. I just wanted to explain how we compute that error rate or successful rate of the AEs. Okay, so we evaluate the AEs here. So in this example, I just evaluate one AE variant. That's FGSM, I think maybe 0.25. No, 0.3, yes. Okay. So we need to load the AE. So in this case, you need to load the AE you generated, right? Okay. And then, yeah, you just use different models to do the prediction. So here, the undefended model, you will get the prediction, and then call this error rate function, fit the predictions on the adversarial examples, and fit the true labels, and provide these corrections, and then it will return you an error rate. Okay, and then we evaluate the ensembles in the same way. You can they all just call the predict this API. APIs are the same, and it's the same for the PGD adversarial trained model. After that, you will get the 3 error rates. I mean, the error rates of these 3 models on the same AE variance. Okay, so that was the function, and here we prepare for the parameters. So load the configurations and specify an output data. Since I don't want to save the output, so I make it false. So you can see it load the baseline model, load the undefended model. In this case, I only show you a very simple ensemble, consists of 3 weak defenses here. So you might see an error rate on this ensemble is not good. Yeah. So we get a result here. So when we evaluate this AE on the undefended model, you can see the 88 above 88% of this AEs can fool this model. And when we go to the ensemble of this just 3 weak defenses, the error rate dropped from 88% to 67%. And when we evaluate it with another defense approach, the error rate will drop from 88% to 21%. So that's how we read this result. Okay, I think that's pretty much.
This is basically related to the trade-off space we talk about, right? Where you can change the strength of ATHENA defense, or basically more accurately change the effectiveness of the defense that you create with the ATHENA framework, right?
Yes.
Given the constraint that you have and basically the number of weak defenses you want to use, the type of weak defenses, the overhead you want to have, because again, these weak defenses are associated to transformations and each come with different costs. I highly recommend you guys to ask questions from Ying, right? So this is a nice tutorial. I guess it is clear and you guys are happy now. But ask your questions to understand what's going on here.
Yeah, please ask questions if yeah, any places you cannot follow or something like that.
I have a quick question. So
Yeah, sure.
the Athena model, that would be the ensemble of weak defenses, right? So do you want us to include a certain amount of those or just whatever we want or all of them?
Yes, yes, you're right. But in your example, I'm not sure whether you should include all the 72 weak defenses.
It is up to you. Maybe you want to also consider different sizes, and in your report talk about like your findings when you use again different sizes. So you're free to explore, and again, the way how you need to think about this project. And again, I mentioned it before, but now since things are much more clear for you, I would like to repeat it. Think about, again, this is a framework which has some flexibility, right? You can consider different styles of ensembles. We have basically like over 70 different type of transformation, but you are free to explore transformations that is not already here, right? And train models of weak defense for this. And we have a script here for doing that, right? In the framework. Construct different instances of the defense with different numbers. Obviously, you don't want to explore like thousands defenses, but design your experiment in a nice way that you could find interesting things and you can write about those interesting findings in your report, right? Think about design of experiment, right? You have some flexibility in the way how you want to design it. I would suggest to step back, think about, design it, brainstorm with other team members. What do you think? Whether it is an interesting design before you even run anything, right? Think about this flexibility that you have. Design it in a way that you maximize the expectation of finding interesting results, right? So for example, you may not get very much different when you have two defense of like size 20 and 21, right? But you may want to have 20 and 30, for example, right? Given the constraint that you have. Basically, think about this, design it, brainstorm with your teammates. And I'm really looking forward to see some interesting design and findings about different aspects of the framework, right? Again, I'm looking for these surprises, and these surprises I'm sure you will find if you come up with interesting design of experiment. Does it make sense?
Yeah, that makes more sense.
Yeah, and if you have question, yeah, ask it now. If any part of this is unclear, Ying is here to help. It may looks like that, like this task may became very trivial, the first task, but that's fine. We wanted to help you and make progress. But it doesn't mean that we will make the other task trivial for you. So this was the first task, a barrier for you. I know, and we should have done it anyway. Now, since you know how to set up defense and work with it, we really expect to explore and do the other task independently. And again, we really appreciate any contribution if you have in terms of bugs that you find, in terms of any sort of contribution that you can imagine. So these are useful. Think about those, and I'm sure you can learn a lot. And you can, we also mentioned about some even future possible research kind of ideas. We wrote it in the project description, and Ying will update it soon with some more ideas I discussed with her, but she needs to update the project description. Yeah, explore any sort of possibilities and learn as much as you can. Because with this framework, I'm sure there are lots of things that you can explore, learn from. So this is very good. One question, how many of you attended the talk we had in CSCE department from Google today? Any of you attended that talk?
Yeah, I attend.
Who? Who is that?
Me.
I cannot hear. Who is that?
I'm Sugar.
I think it's Sugar. Yeah.
Okay. Only Shuge attended, or anybody else? Do you have something to say, Shuge, about the talk and the relation of the talk and what kind of challenges the guy discussed with respect to what we have discussed in this class?
I think the guys discuss how to predict the customer whether buy something, but I'm not sure what I'm not that clear what he's doing.
You didn't you couldn't follow his talk. It was super clear.
It's clear, but I don't quite understand the technical.
Yeah, but not technical at a high level. Did you find any connection between kind of challenges he discussed about, the pipeline that they have for marketing analytics?
Oh,
because
yeah.
he was talking about the marketing analytics, right? Which is, you can think about this as a machine learning system at a scale, right?
Oh, there is something. Yeah.
Did you learn anything, or you want to discuss that has any relationship between this course and what he discussed at a high level, not like detail of advertisement or marketing analytics? I don't know either about those details.
So if there's some connection, I think their pipeline is similar to the machine learning systems. Yeah, the whole pipeline. But I don't know whether it's too much details. And also I think how to identify the problems or the questions is important. Yeah, so if he is going to predict whether the customer will buy the product. So how to identify the problems.
How they formulated, you remember how they formulated that? So let me maybe you didn't listen carefully, right?
Yeah.
So any other students attended? Shugei was the only one? Okay, so that was interesting talk because this guy he was an engineering lead at Google who I invited to give a talk here in our graduate seminar. And for me, it was interesting. He was mainly talking about marketing analytics and their pipeline, which is basically at an abstract level is the data is the behavior of customers that they have, right? How they interact with their product, right? And they collect many of these customer behavior, and they do analytics on top of these data. Basically, they use many different type of models, from neural network to logistic regression to ensembles. Basically, mention they as long as any model provide decent accuracy based on the data they're using, and they are using many different models, right? And he was talking about some challenges when it comes to several hundred or several thousands models needs to maintain and needs to serve. So basically, they have one model per customer, and customer means that, like, imagine a company having a website, right, and doing the advertisement or selling some stuff, right? So at that scale, so it means that like maybe even millions of models they regularly train on the data, update and serve the customer. So he was mentioning one model per customer, which was interesting to me. And he mentioned about these model updates that we discussed at the beginning of this course. If you remember, he was talking about the pipeline from data to model training to serving, updating the model, how the update of the model looks like, what kind of metric they care for when they decide to do model update. For me, it was surprising that also, I mean, it's not really that much surprising, but I thought their model update is fully automated, but apparently it is not. So human is in the loop to decide when they need to update the model, and in some cases he was mentioning that they fall back to the even very old model or some model that they know that previously have worked, or even no model case, meaning that they use prior information to decide. So basically, it was interesting to me that he was mentioning these challenges, and it was very much connected to what we have discussed so far in this course. Yeah, and this was a particular team at Google, basically marketing analytics, but having, I talked with several other folks at Google in different teams, right, advertisements, infrastructure, beyond Google also, Facebook, for example, and some other smaller companies, smaller, I mean smaller than Google, Facebook, but to some extent medium size. it was several weeks ago. It was AI Summits. I gave a talk there, and then talking with some folks from industry, again from these like smaller companies. They had all sort of these issues that we touch in this course, and it was interesting and assuring to us that we talk about relevant stuff. So try to messages that try to learn as much as possible in this course. It would be very useful for you guys. Either again, the path could be either if you are interested going to industry doing machine learning, this is the way to do it. If you are interested doing grad school or doing like advanced research in machine learning, this is also useful.
Was there a recording of the talk?
I believe the talk was recorded. Yeah, reach out to Sanjeev. He's moderating this course, seminar course in our department this semester. But the talk was recorded, yes, and will be available, I believe. But I'm not sure to what mailing list he will going to send, whether it will be reached to you guys. But if I found out, I will post it on Piazza for you.
All right, thank you.
Any question, thoughts? If not, maybe we can start talking about convolutional nets. Continue our discussion there.
Okay, I'm stop sharing now.